This is problem number 10 from chapter 11. It says here that car manufacturers are interested in whether there's a relationship between the size of the car an individual drives and the number of people in the family. And to test this, we suppose that 800 car owners were randomly surveyed and the following results. Conduct the test of independence. So clearly, this is a hypothesis test for independence. And in our hypothesis for independence, we're going to use a chi-square distribution. And in our chi-square distribution, the degrees of freedom is going to be the number of rows minus 1 times the number of columns minus 1. So we have 4 rows. 4 minus 1 is 3. We have 1, 2, 3, 4 columns. 4 minus 1 is 3. By the way, these numbers here are not part of our data. Our contingency table is this 4 by 4 matrix, or 4 by 4 cell block. And these over here are just categories, just like subcompact, sub and compact, mid-size, full size, and van or truck. Okay, so this is our setup. So our degrees of freedom is 9. So this is going to be our distribution, chi-square sub 9. Now, to begin our hypothesis test, or one thing to also note is in doing our hypothesis test, our test statistic is going to be just like the goodness of fit test. It's going to be the sum of the observed minus the expected frequency squared divided by the expected frequency squared. But instead of just running through a set of numbers, we're going to run through 2 indices here, I and j, and it's going to go through each row and each column. So we would, I guess in the old days, they would find the expected frequencies, and these are the observed frequencies right here. So the expected frequencies they would get and then put into this formula. Now, how would you get the expected frequencies? Each of these cells would have their own piece of information. And so expected frequency for this particular cell, for example, is going to be the sum of the rows. So that's 70, 110, 130, and the sum of the columns, this would be 80, and then divide by the subtotal. The subtotal, there are 800 cars here, so car owners. So it's going to be 130 times 80 divided by 800. And that's going to be your expected frequency that would go in this cell. And then you would proceed to fill in the rest of the cells with their own expected frequencies. We are not going to do that. Instead, our calculator will get that for us. And it turns out that for a very nice program in our calculator, we only need to input the observed frequencies. The calculator will calculate the expected frequencies for us, and as well as the rest of the hypothesis tests, like the test statistic and even the p-value. So to run our hypothesis test, we need our hypotheses, and you can say in this case that the family size for your null hypothesis, the family size is independent of the kind of car purchased. So the key word is that it's independent. And then for the alternative hypothesis, you can say the row and column categories, or you can restate everything over again and just say dependent. but I'm going to say something different here. It says just say row and column categories are dependent. Alright, so let's run the test to get our p-value, our test statistic. Is a chi-squared test statistic and our p-value. Alright, to our calculators, we press stat and test, and I'm going to go up, and it's going to be a chi-squared test. Actually, before we go into the chi-squared test, if you look at it, you'll see that it's looking at the observed and expected frequencies. So this is a symbol for a matrix in your calculator. So what we need to do is we need to fill in our matrix. And the good news is that we only need to fill in the matrix for A. So I press second function, and the matrix for me is up here. If you have an older TI-83 calculator, then you might have to look for your matrix button. I'm going to go to Edit, and I'm going to select A, the first one. I'm going to adjust the size to the appropriate size. Again, this is a 4 column by 4 rows. The first number here is the number of rows. I'm sorry, that's 4 rows and 4 columns. So the first number is the number of rows, the second number is the number of columns. In this case it's the same, so it didn't matter, but you could have some contingency tables where it's different. And then we put in those values that they have. So we have 20, 35, 40, and then if you just right arrow to the next one or press enter, you'll see that the 4x4 matrix is not going to fit in a screen here, but the calculator will adjust to it. Alright, let's fill in the rest of the stuff and proceed to get our test going. So hopefully this is all looking correct. Let me come back here and double check on this value here. It looks like we inputted this. I inputted this incorrectly. Instead of a 0.5, it's a 35. That would have been a big mistake. So we just need to be careful about making sure that our data is inputted correctly. Now let's go back to the stat, test, and chi-squared test. So in our chi-square test, everything is all set here. The observed frequencies is in your matrix A, the expected frequencies are in matrix B. Notice we didn't change it, but it'll automatically change for us. Just in case, if this does not have your matrix A in it, what you can do is you can go back to your matrix button. So while your cursor is here, I press second function and matrix. And instead of going to edit, I'm just going to select A. Oh, one more note before we leave the screen. The matrix B is a 5x2 right now, but after we run the test, it'll overwrite that matrix and it'll give you a 4x4 matrix with the expected values. So I selected A, and here's my matrix. Now remember the calculate versus the draw. Calculate and draw gives you the same information, except the draw will give you an added drawing. Let's do both. I'm going to press calculate for now. Calculate actually gives you another piece of information. It's going to give you your degrees of freedom. So what we have here is a 15.828 and a p-value that's very close to our deciding factor. It doesn't say what our significance level is, but we usually choose 0.05, so it looks like it's bigger. Our degrees of freedom is 9. We can confirm that. How would our drawing look like? Let's go through the same thing again. So if we do a chi-square test, and instead of hitting calculate, we go to draw. So it's going to give you the chi-square distribution, which is a skewed to the right distribution. It's going to mark off a chi-square value of 15.828, and the shaded region is your p-value, which is 0.0706. Okay, looks like our p-value is greater than our significance level of 0.05, our default significance level. So it looks like we're failed to reject the null hypothesis. So we failed to reject the fact that the hypothesis that says that this is independent. So we can go back and say that this was we failed to reject it. So it looks like it is in fact independent. It seems like the family size and type of car purchased is independent. Alright, so this is the end of the test, but I told you about the expected frequency. So if we want to view that, let's go back to matrix again. Second function in matrix. And notice our B now is a 4x4 matrix. Let's click on that. So I'm in my home screen. I have B flashing here. If I press enter, I'll see the matrix for B. That's kind of difficult to read. So what you can do is, to view this in the matrix form, let's go to edit and then select B again. So might be a little bit easier, but this gets cut off, so we need to arrow to the right. But in any case, our information is given here. Our expected value for the first cell is 13. Expected value for the next one is 22, and then 26 and 19. Expected value here becomes a decimal, but we can round off, so let's call it 27, 45, 54, and 39, and then etc. So we can find that to get this last column in the matrix, I just arrow one more, and then I get that last column figured out. So you can fill in the rest of this information with your expected value that you get from your calculator. Okay, hope that helps.